some ways, black holes are kind of like the drains in the bottom of a cosmic bathtub. Anything that gets near them spirals down into them, into darkness. Out of sight, out of mind, out of the universe as we know it. And they're pretty much immune to clogging up as well. So perhaps our first and most logical port of call, if we were to somehow build one of these things, would be waste disposal. Because if black holes consume everything that gets too close to them into inescapable oblivion, which they do, but we had one under our control, then we could stop worrying about our trash and plastics and, well, anything we no longer needed. We could just tip it into the first singularity we built and boom, the world is a cleaner and tidier place. Except maybe it's not that simple. There's no question that a black hole could eliminate anything we threw at it, sure, but the sun could essentially do that too. And we're not yet launching all our trash toward the center of the solar system. Why? Well, mostly because it's a long way away. And the same would go for most black holes we could ever imagine building. The classic stellar black hole forms when a dying star collapses, compacting an unbelievably large mass into an incredibly tiny space. If we wanted to build one then, we'd need some way of controlling star destruction first of all, which is a big ask. However we do it though, all of that matter and energy in one place creates a correspondingly massive gravitational distortion in space and time, which is what draws matter into the black hole and into its event horizon. But the sheer size and power of this gravitational effect is precisely why we couldn't reasonably expect to use a black hole to get rid of our unwanted things. Not unless we wanted to get rid of the rest of Earth with them. The only safe, non-Earth consuming place to build a stellar black hole would be well outside the solar system, at which point the idea of sending our trash into it gets even more ridiculous and unfeasible. The sun suddenly seems a more realistic option. That is, unless we were to develop some new, incomparable energy source with which to power shuttle runs from here to our black hole out in space. But here's the thing with this particular hypothetical scenario. It could solve itself, because if we could build a black hole, then it might actually serve as exactly that, a huge new source of energy. There's a misconception that black holes are simply where everything goes to basically die, but they're also sites of immense energy potential. Spinning black holes drag at the space around them, creating a region where space itself is moving at incredible speeds too. This region is known as the ergosphere, and crucially, it isn't quite as inescapable as the event horizon is. Therefore, there are theories that it might be possible to launch an object into the ergosphere, then accelerate it enough to fling it right back out again. Kind of like how regular space probes slingshot around something just like Jupiter to increase their power. Angle our ergosphere-bound object just right then, and when it reemerges, it could have effectively stolen energy right out of a black hole. This idea was first proposed in 1969 by Sir Roger Penrose, while more recent experimental data using sound waves has shown that it actually could work. To take it up a level, by using the Penrose process, we could also build something called a black hole bomb, which, while it sounds like a sci-fi style singularity-based superweapon, actually isn't. We'll talk weapons later. Instead, a black hole bomb would be a physical shell, built by humans, around the outside of the black hole, designed to efficiently harvest all of the energy possible via interactions in the ergosphere. According to the physicists Marion Crom and Danielle Faccio, writing in the Nature Physics journal in 2020, the energy we could get out of a structure like this would be limitless. Of course, the vast majority of the technology we'd need to achieve anything even remotely like this is still so hypothetical it's practically a fantasy. On paper, it possibly works, but in real life, we're extremely far away from even beginning to make it happen. Right now, we don't even have access to a black hole to squeeze the juice from, the nearest one being about 1,000 light-years away. But that's why a hypothetical world in which we can build one opens up so many more possibilities. Such a development would certainly send humanity much closer to becoming a Type 2 or even Type 3 civilization on the Kardashev scale. It's exciting then, or maybe unnerving, that scientists are making progress in this particular field. Because while your garden variety black hole tends to form out of a collapsing supernova, you don't necessarily need a whole dying star on hand to create one. In theory, you can form a black hole whenever enough energy or matter is compressed into a small enough area of space. Something which could happen, for example, if you fired two particle beams at each other like they do at CERN's Large Hadron Collider. The experiments at the LHC have long been fodder for doomsday predictions, where a sprawling black hole explodes out from beneath the Franco-Swiss border and instantaneously destroys the world. But really, there's no need to panic just yet. Any black hole the LHC spawns would be subatomic in size, and it would be here and gone in an instant. The debate is certainly ongoing, but most scientists working at CERN are quick to dispel any fears of disaster. Still, it's an unfortunate reality that discussions on black hole creation very often lead to another aspect of this pioneering science. How could we weaponize it? It's been estimated that the emergence of even a tiny black hole, smaller than a penny, could bring with it multiple atomic bombs worth of energy and destruction. The sudden emergence of something as massive as a stellar black hole, and the entire solar system would be under threat. But for any civilization that has successfully built a black hole bomb just to siphon off the energy, for any society with control over such immense power, ultra-destructive weapons like these would be easy to conceive and simple to make. But then why stop there? Were a civilization to have learned how to build and control one black hole, couldn't they just as easily build and control two of them? And couldn't they then smack those two together to generate even more energy for, amongst other things, bigger and more devastating weapons? When two black holes approach each other, space further bends around them, sending out ripples known as gravitational waves. By the time they collide, space-time has been even more severely warped, and more powerful waves have been sent out, until finally the black holes merge and release one final colossal wave of gravity. These events generate such incredible energy that, in 2017, astronomers observed an entire black hole apparently being launched out of the heart of a distant galaxy, probably as a result of a black hole collision. If we were able to tap just a tiny percentage of the energy produced here, then we'd have enough energy to fuel ourselves for countless more generations, or enough energy to destroy pretty much anything we wanted to. Whole star systems if we felt like it. Let's just hope that no one would ever be willing to pull the trigger on a weapon like that. Clearly though, if any of this hypothetical scenario is ever to actually happen, then it'll all be far into the future. And if we somehow magicked our first black hole tomorrow, we'd still probably never live to see the technology needed to build black hole bombs, infinite power sources, galaxy-ruining weapons, or even never-ending garbage chutes. For the 21st century human, there are simply too many major unknowns. Add into the mix the increasingly popular theory that black holes might have an other side in the form of a white hole, a theoretically opposite structure where matter is infinitely repelled and rejected, and all the reasons to continue to study them mount up and up. Experiments at the LHC aren't all geared toward black hole creation, but if humanity ever did reach a point where birthing these things was common practice, well, we'd have advanced to an almost inconceivable level. Today, there are so many theories about black holes that we just can't test out, but generate one of our own, and we'd be so much closer to finding the answers. If we could find a way to survive the awesome power they unleash, then we'll have opened the door to knowledge like we've never dreamed of. And that's what would happen if we could build a black hole.